Hi everybody, welcome back to Climate Change Calculated, a Corona update. And today is about the estimation of the effectiveness of our vaccines against the new Delta variant. My name is Gerald Schuller. First, our parent website is this link here, where you can find the slides that I'm presenting and also more links. Then the connection to climate change. What is the connection between the coronavirus and climate change? Climate change causes shifts in habitats of animals and plants, and this leads to new contacts and encounters between animals and humans. And this in turn leads to increased opportunities for viruses to jump between species. And this is the origin of new and dangerous viruses and pandemics, because if new viruses come from animals to humans, our human immune system doesn't know how to fight it. In this plot, you can see the concurrently sick in Germany in comparison with my model from March of last year. So the concurrently sick are the number of infected minus the number of recovered. So it's really the people who are concurrently sick, and those are the ones who are infectious. So here in this plot you can see in orange the number of concurrently sick in Germany. And you can see here it starts in April of 2020 and goes up to August to 2021. And in blue you can see my logistic model, which I developed in April of 2020. So this was my forecast, which I also called a possible solution, because it shows how this virus would spread in a way that we can contain it. That's why I called it a possible solution. And you can see that the real number of concurrently sick more or less follows my solution curve. And that is because we had those lockdowns here, those countermeasures. So when there was too much growth in the virus spread, then we had the countermeasures here. The first lockdown, it really was very effective, went down during the summer, and then in the fall, it was rising again. The virus was spreading, and then in November, December, we had a new lockdown. So we got a peak here in Christmas, around Christmas time last year. Then we had the new lockdown. It went down a lot until the lockdown ended. So here in the beginning of March, it went up again. And you can see it's actually, despite the peaks here, it's actually quite close to my blue curve of the solution here. And my blue curve, the model actually ends in April, because I assumed that at this point we would have enough vaccines to influence the spread of the virus, which indeed happened. It's not quite at the beginning of April, but you can see here more like the end of April, so it was like a month late. Indeed, we see an effect of the vaccines. So now it goes down a lot. Goes down and down and down until the beginning of July. So here you can see in the beginning of July we have a trend reversal. So now here we are at the bottom, and now it goes up. And this coincides with the time when the new Delta variant of the coronavirus becomes the main ingredient of the coronaviruses that are spreading. So here at this point, roughly, the Delta variant became the major variant in Germany. And since this is much more infectious, you can see the rise. So here, this is mainly probably because it infects also the one-time vaccinated, unlike the previous variant, which also only one vaccination was a good protection. This plot shows you now the concurrently sick per million inhabitants internationally. So this is interesting also to compare how different countries deal with the virus and how the virus evolves over time. So you can see here the same time span from April 2020 until now, early August. And now it's normalized to the number of inhabitants in millions. So that also makes different countries of different sizes comparable. So you can see in orange is again the curve of Germany. And for instance, here in violet, we have the curve of the US. And then there's also the curve of the United Kingdom in brown, which we can see here. And we can see they all have this uptick here of concurrently sick. So most countries in the world actually have this uptick. And it's all because the Delta variant is spreading. And it was spreading particularly early in Great Britain, in the UK, which you can see here in this brown curve. It actually has this peak here again in January, like we had. Then it goes down, but now it goes up again. And you can see here it goes up much earlier than Germany, which we can actually more easily see when you zoom in here. So we can easily zoom in using the zoom tool to early this year. So now you can see the time from March to August. And you can see that Great Britain, the UK, had a minimum around mid-May. And then it was increasing again because then the Delta variant took over. So you can see here from mid-May to about mid-July, we had an increase. And it seems now they are over the hump. So now they are going down again. So that's a time span of about 2 months, which it took them to go from the bottom to a new peak. And since in the UK we have roughly a very similar number percentage-wise of vaccinated people as Germany, I think we can take this as a comparison to what will happen to Germany's numbers now. So you can see here Germany's numbers. They went bottom in the beginning of July and now they are rising again. So you can, making this comparison, you can think that it takes 2 months until we reach the top. So that will be July, August, September. So basically early September probably we will have this peak here. Now this plot is very good for predicting the rise and fall of our curve because it shows the factor of increase of concurrently sick. So this shows the daily factor of increase from one day to the next, averaged over a 7-day period to make it appear more smooth. And everything above 1 means the number of concurrently sick is increasing. Any number below 1 means the number of concurrently sick is decreasing. And you can see here again, Germany, the orange curve. You can see that at around beginning of July, we crossed this line from decreasing to increasing. So here we got the start of the increase of the concurrently sick from the coronavirus because of the Delta variant. And you can see it's going up. And now it stays close to 1.05, which is somewhat lower than the UK was before. So again here the brown curve shows the curve of the United Kingdom. And you can see it is a little bit above 1.05. So they had a larger, higher growth rate. And you can also see here now they actually went below 1. So that means since about end of July, now they have this decline, which we just saw in the previous plot. And we can also shift this plot to see since when it was going on for the UK. So here you can see where it went above 1 the first time, was around here. So mid to end May, this is when the Delta variant took over. So again, it's about these 2 months which led to this wave because of the Delta variant in the UK. So you can see here now that Germany and also here Japan, and here you can see the US. The US crossed this curve end of June. Japan is in early July, so they're about a few weeks earlier than Germany, which was on July 11th. So you can also see they have similar increases, except that Japan now has a surprisingly high increase here, surprisingly high growth rate. Also, the US has a relatively high growth rate here. But using this precedent from the UK, you can say that during the next 2 months, probably due to the Delta variant, they will have increased cases of concurrently sick. Here in this graph, you can now see the vaccination rates of different countries here in this bar plot. So the dark color shows people fully vaccinated, and the light green is the share of people only partially vaccinated against COVID-19. And you can see here in the top group, you have Canada, United Kingdom, Spain, Italy, France, Germany, and the United States. So, for instance, here the United States have 49% fully vaccinated and 8% partly vaccinated, so meaning just one vaccine shot. So a total of 57%. And Germany has very similar numbers. And then going to the United Kingdom, we have 69% fully vaccinated. So that basically shows that the United Kingdom here is actually in a pretty good position, even slightly better than Germany with a number of fully vaccinated. But in the same group, you can say. So that's why you can say that this is kind of a good model for what will happen in Germany during the coming 2 months. This plot shows the proportion of the viruses which are the Delta variant over time and for different countries. And you can see, for instance, the United Kingdom is here. Here you can see that already in April, it became significant in the UK. And in the meantime, it's basically 100%. So comparing that for Germany, so Germany is here. So here you can see that in Germany it became significant during June, and now it's over 80% already. So it's already dominating the coronaviruses. And it's quite similar here in the United States. It became significant in June, and now we have about 90% in the United States. Yeah, and this leads me to an important point I want to make today. The effectiveness of 1 or 2 vaccinations against the Delta variant using probabilistic theorems, the Bayes theorem. So the following shows that even from a relative small sample size, we can make useful predictions. So for that, we can use data from Great Britain from the end of May. So this is actually when the Delta variant already took over. So here I found this Nature article with a few interesting numbers. For instance, this one here. Some 5 out of 18 hospitalized people testing positive for the variant had received a single dose of the vaccine, and just 1 had been given both doses. And observe that these are low case numbers, but we still can get useful estimates using the Bayes theorem. So in Bayes terms, it means we have a probability of 1 vaccination given the hospitalization, and this is 5/18. So 5 people out of 18 had just 1 vaccination, right? So given those people in the hospitalization, those 18 people, 5 of them had 1 vaccination. So the probability out of this group of 18 to have just 1 vaccination is 5/18. Right? So this is the probability. And the base term here is the given. Given some condition. Here, given the hospitalization. So we have a probability given this condition, in this case, the hospitalization. So the notation used in Bayes' theorem is usually we have 2 cases, B and A. B would here be the vaccination status. A would be hospitalized with COVID. And P of something would be the probability of something. And then this given is short named by this vertical bar. So this vertical bar means given. So hence, in short, we have probability of B1, meaning just 1 vaccination, given A, the hospitalization, is 5/18. The probability of 2 vaccinations, B2, given A, the hospitalization, is 1/18, because just 1 had 2 doses. Then the probability of no doses, so B0, given hospitalization, is the rest, meaning 12/18. So this is now what we can learn from this article. But we want to know the opposite. We want to know the probability of hospitalization given the vaccination status. Right? We want to know how well does protect 1 or 2 times vaccinations against the Delta variant. But we have it the other way around. And Bayes' theorem gives us the answer. It shows us how to do it. So here the first line is actually Bayes' theorem. So it says B of A, the hospitalization, given B, the vaccination status, equals P of B given A, so this is what we just had, times P of A, the probability of hospitalization in general with COVID, divided by P of B, the probability of our vaccination status. So this is the formula we need. So all we need now is P of A, the probability of hospitalization with COVID in general, and P of B, the probability of the vaccination status. And since we only want to know how much more does 1 or 2 doses compared to no doses of the vaccine help, we can set them in relation. And if we set them in relation, then what we find is that the P of A cancels out. So all we need to know is the probability of the vaccination status. And this is actually what we saw in the previous plot, in the previous bar plot. We saw the probability of vaccination in Great Britain for 1 dose and 2 doses. And it also has the data for end of May. So we can just look at this website, at the data for May, and plug it in here. So we could just go to the plot above and look for the end of May date, and we will see the probability of no vaccination in the UK at that point was 42%. So at that point they had just a little bit more than half of the people with at least 1 COVID shot. And then the probability of just 1 vaccination was 21%, and 2 vaccinations was 37% at that time. So now basically we have all we need. We have the P of B given A, and we have the P of B, which we just saw here. And the P of A cancels if we put them in relation. So we don't need P of A if we compute the ratios, because then it cancels. So here's the ratio of the probability of hospitalization with 1 vaccination compared to no vaccination. So here we have P of A, B1, divided by P of A given B0. Right. So then we plug in Bayes, and this is what we get. Observe that I already canceled the P of A. So all we need here is what we just derived, and when we plug it in, we get 0.83. So the probability of hospitalization with one vaccination is slightly lower than with no vaccination, but not a big deal. Right, so if it would be the same, it would be 1.0. Here it's reduced to 0.83. So percentage-wise, it would be 17%. Right, so 100 minus 83. Then, interesting is also the next point. Here I'm comparing hospitalization with 2 vaccinations compared to no vaccination, and I get a 0.094. And this is a dramatic difference, right? Compared to 1.0, which would be no difference, here we have a big difference. So in percent, it would be, instead of 100%, you just have 9.4 9.4%. So an over 90% reduction in the likelihood of hospitalization. So 2 times vaccinations really help also against the Delta variant. So here the summary. 1 vaccination does not give much protection against the Delta variant. It reduces the probability of hospitalization compared to no vaccination only by a factor of 0.83, or about 17% less than with no vaccination. Observe that this is different from the previous corona strains against which also 1 vaccination gave a good protection. In most countries, less than 50% of the population is fully vaccinated. So this is the opportunity that the Delta variant is now taking. Right? It uses the fact that not everybody is fully vaccinated. But 2 vaccinations give us a very good protection by a factor of 0.094, or about 91% reduction in the risk compared to no vaccination. So I can just recommend everybody to get a full vaccination, because that gives a good protection also against the Delta variant. Okay, thank you for your attention. That's it for today, and see you next time. Bye-bye.